NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will simplify a nested radical step by step, following a clean algorithm that turns a scary expression into something elegant. Here is the example we will simplify. Notice the sixth root, and inside of it, the fourth root of 4. We will convert and simplify carefully. Our goal is to reach a compact, exact form. Step 1. Convert the fourth root of 4 into simpler radicals. Since 4 is 2 squared, the fourth root of 4 equals the square root of 2. Step 2. A sixth root can be viewed as the cube root of a square root. That is, the sixth root of x equals the cube root of the square root of x. We will apply both of these moves now. Next, focus on the inner square root, the square root of 99 minus 70 times the square root of 2. We will rewrite 70 times root 2 as a single square root. Since 70 root 2 equals the square root of 70 squared times 2, that becomes the square root of 9,800. Now the inside matches the form, square root of a minus the square root of b. Here is the classic identity to crack nested radicals. For positive numbers a and b, if c squared equals a squared minus b, then the square root of a minus the square root of b equals the square root of open parenthesis, a plus c close parenthesis, over 2 minus the square root of open parenthesis, a minus c close parenthesis over 2. In our case, a equals 99 and b equals 9,800. Compute c squared. Since c squared equals 99 squared minus 9,800, that is 9,801 minus 9,800, we get 1. With c positive, c equals 1. Now substitute into the identity. Evaluate each term. 99 plus 1 over 2 is 50. 99 minus 1 over 2 is 49. So the expression becomes the square root of 50 minus the square root of 49. Now simplify further. The square root of 50 is 5 times the square root of 2, and the square root of 49 is 7. Recall, our original expression now reads the cube root of that inner square root. Substitute the simplified form to finish. Therefore, the sixth root of 99 minus 70 times the fourth root of 4 equals the cube root of 5 times root 2 minus 7. Quick check. If you square the quantity square root 50 minus square root 49, you get 99 minus 2 times the square root of 50 times 49, which is 99 minus 70 times root 2. That confirms the inner step is correct. And that completes the simplification. That confirms the inner step is correct. Simplify the square root of 4 plus the square root of 7, using the half sum and half difference identity. Next, apply the same identity to square root of 4 minus the square root of 7. Now simplify the inner radical, square root of 4 minus 2 times square root of 3. We will rewrite it and reduce it to square root of 3 minus 1. Use that result inside the next radical, square root of 3 plus square root of 4 minus 2 root 3. Substitute and simplify. Finally, substitute each simplified part back into the original expression, and combine like terms carefully, and simplify. Finally, substitute each simplified part back into the original expression, and combine like terms carefully. Finally, substitute each simplified part back into the original expression, and combine like terms carefully. Here is the expression we will simplify. Our strategy is to rewrite each square root using a classic identity. If a squared minus b is a perfect square, say t squared, then the square root of a plus square root of b equals the square root of a plus t, all over 2, plus the square root of a minus t, all over 2. The minus version uses a minus sign between the two terms. In our problem, a equals 4, b equals 7, so a squared minus b is 16 minus 7, which is 9, and t equals 3. First, compute the square root of 4 plus square root 7. Substitute a equals 4, and t equals 3 into the identity. Now, simplify the fractions. Rewrite each as a product with 1 over square root 2. Combine over 2 to get the exact compact form. Next, compute the square root of 4 minus square root 7. Using the minus version of the identity, simplify to the same denominators, and express it with surds over 2. Now subtract the two results. Substitute the expressions we just found. The square root 14 terms cancel, and the square root 2 terms add. The entire difference simplifies beautifully to square root 2. Finally, apply the outer 55th root. We have the 55th root of square root 2. Using the property that the nth root of the mth root of a equals the n times mth root of a, the answer is the 110th root of 2. In this lesson, we simplify a beautiful nested radical step by step. We'll follow the innermost square root outward, using perfect square patterns to make everything collapse cleanly. Step 1. Simplify the innermost part. Start with the square root of 13 plus square root of 48. Rewrite square root 48 as 4 times square root 3. Now, notice a perfect square pattern. 13 plus 2 times square root 12 equals open parenthesis, square root 12 plus 1, close parenthesis squared. Therefore, the square root becomes square root 12 plus 1. Step 2. Substitute this result into the next layer outward. Replace the inner radical to get the square root of 5 minus open parenthesis, square root 12 plus 1, close parenthesis. That simplifies to 4 minus square root 12, which equals 4 minus 2 times square root 3. Step 3. Recognize another perfect square pattern. For minus 2 times square root 3 equals open parenthesis, square root 3 minus 1, close parenthesis squared. Taking the square root gives the absolute value of square root 3 minus 1, which is positive here, so it becomes square root 3 minus 1. Step 4. Substitute again into the outermost radical. The original expression becomes the square root of 3 plus the quantity square root 3 minus 1. Combine like terms inside. That is 2 plus square root 3. Final step. Write this well-known radical in exact closed form. Assume square root of 2 plus square root 3 equals square root a plus square root b. Squaring gives a plus b plus 2 times square root of ab. Match parts. A plus b equals 2 and ab equals 3/4. Solving yields a equals 3/2 and b equals 1/2. Therefore, the square root of 2 plus square root 3 equals square root 3, has plus square root 1/2, which is open parenthesis square root 6 plus square root 2, close parenthesis over 2. So the entire nested radical simplifies to open parenthesis square root 6 plus square root 2, close parenthesis over 2. We want to simplify the square root of x plus 2 minus 2 times the square root of x plus 1. A great pattern to recognize is the square of a difference of square roots. The quantity square root of u minus square root of v, all squared, equals u plus v minus 2 times the square root of uv. Now match our radicand to this structure. Choose u equal to x plus 1 and v equal to 1. Then u plus v minus 2 square root of uv becomes x plus 1 minus 2 square root of x plus 1, which is exactly our radicand. So the expression under the square root is a perfect square. That means the original radical equals the square root of the quantity square root of x plus 1 minus 1 all squared, which simplifies to the absolute value of square root of x plus 1 minus 1. We must consider the domain. The inside x plus 1 must be non-negative, so x is at least negative 1. The absolute value becomes two cases. When x is greater than or equal to 0, square root of x plus 1 is at least 1, and the expression equals square root of x plus 1 minus 1. When x is between negative 1 and 0, it equals 1 minus square root of x plus 1. Many exercises assume x is at least 0, so the absolute value is non-negative by default. Under that common assumption, the simplified form is square root of x plus 1 minus 1. Quick check. If we square the simplified expression, we get x plus 1 minus 2 square root of x plus 1, which matches the original radicand perfectly. That completes the simplification with a clear domain statement. In this lesson, we will simplify a nested radical step by step, following a clean algorithm. Here is the problem. Our goal is to simplify the expression, the square root of 1 plus the square root of 3 plus the square root of 13 plus 4 times the square root of 3. Step 1. Focus on the innermost radical, square root of 13 plus 4 times square root 3. We will use the standard form square root of capital a plus square root of capital B. For that form, there is a helper number capital C defined by C equals the square root of a squared minus b. In our case, a equals 13 and b equals 48 because 4 squared times 3 is 48. So C equals the square root of 13 squared minus 48, which is the square root of 169 minus 48, which is the square root of 121, equal to 11. Step 2. Use the identity for a single nested radical. Square root of a plus square root of b equals the square root of a plus c over 2 plus the square root of a minus c over 2, where c is the number we just computed. Substituting a equals 13 and c equals 11 gives square root of 13 plus 4 times square root 3 equals the square root of 13 plus 11 over 2 plus the square root of 13 minus 11 over 2, which simplifies to square root 12 plus 1. Step 3. Substitute this result back into the middle radical. We get the square root of 1 plus the square root of 3 plus the quantity square root 12 plus 1. Combine the 3 and the 1 to make 4. That becomes the square root of 1 plus the square root of 4 plus square root 12. Step 4. Notice that the square root of 4 plus square root 12 equals square root 3 plus 1, because the square of square root 3 plus 1 is 3 plus 1 plus 2 times square root 3, which is 4 plus square root 12. Therefore, the expression becomes the square root of 1 plus the quantity square root 3 plus 1, which is the square root of 2 plus square root 3. Step 5. Simplify the remaining single nested radical using the same idea. Write it as the sum of two square roots. Let the square root of 2 plus square root 3 equal square root a plus square root b. Then a plus b equals 2, and 2 times the square root of a b equals the square root of 3. So ab equals 3/4. One convenient choice is a equals 3/2 and b equals 1/2. Therefore, the expression equals square root 3 over 2 plus square root 1 over 2, which simplifies to the square root of 6 plus the square root of 2, all divided by 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.